graphing radical functions simply means we're focusing on graphing square root functions today. All right, and all of those translation rules we had talked about many, many times along the way are coming back into play today. Okay, so here's some things I want to remind you of. First of all, we started talking a little bit about a square root. The graph of the parent function y equals the square root of x is a graph that starts at the origin and curves up ever so slightly. So you figure when x equals 1, y equals 1, right? When x equals 4, y equals 2, you can see where that graph starts going around, right? So this is the basic graph. Now, we're going to take this parent function, we're going to do some moving around on it. So, following this idea, if I have y equals, what letter did we always put in front of where x was being housed? A, yes, A. Then we have the square root of x minus, what letter did we use next? How about h? Yes. Yes, exactly. You guys have learned this. You have. You have. And then, at the end, we're going to have plus k. Okay. You learn this as a, I'm going to come down here, as a parabola or a quadratic. I said you learn these rules in the beginning, you will know them every time. We did y equals a times x minus h squared plus k. Yes, we did. Same things are happening here. Okay? All right, now it looks familiar? Okay, let me say this one more time. This, when you learned it, the parent function was y equals x squared, right? It was a quadratic. This was y equals x squared. The same translation rules are going to apply here when our parent function is y equals the square root of x. Same things. You have a set function that we are going to stretch, compress, move right, move left, flip. Okay? Same things. Are we now on the same page? Okay. All right. So, as I was originally saying, in here, this a, remember when a was greater than 1, we said this was a stretch. Between 0 and 1, it was a compress. If a was less than 0, then it flipped. Right? If it was negative, anywhere. What? No. Oh, just give me a second, okay? You don't remember this equation? All right. So let me keep going, guys, okay? Please. All right. As I was saying, then we always said wherever x was, we could set equal to 0. And this told us, h told us whether we moved right or left. Then whatever was added to the very end of our function, we said was up or down. All right, so back in the day, if we had, for a parent function of y equals x squared, if we had y equals 3 times x minus 4 squared plus 5, You guys all told, whoops, y'all told me back then that this was a stretch of 3. This went to the right 4, and that was up 5. So, if I have y equals the square root of x as the parent function, and I have y equals 3 square root x minus 4 plus 5, stretch 3, right 4, up 5. Same exact thing. Okay? Are we all good right now? Okay, so here is where I want to start. First thing I want to start with is talk about example number 1. Describe the translation. If I give you for the parent function y equals square root of x, if I say y equals negative square root x plus 3 and then minus 7 on the outside, this negative tells me I'm going to what? Flip. So it actually is going to be flipped underneath. Underneath here, we always said, remember that you have to take this technically and set it equal to 0 and solve it, right? This tells us we're going to the left 3. And this one told us we were going down 7. Okay? Hopefully this is now sounding more familiar. Okay. All right. So I want to do one more. What if I gave you y equals 1/3 the square root of 2x plus 1 plus 5? This a in front is going to tell me that I am compressed 1/3. That means it's going to be flatter by 1/3. Tell me, are we going right or left? Left how much? 1/2. Very good. If we were to take this 2x plus 1, set it equal to 0 and solve for x, we get x equals negative 1/2. And then at the end, of 5. Perfect. Okay? So now, we're going to use that idea to graph today. All right? So here's example number 2. Yeah. Yeah, it's just that your parent function is different. That's it. It's nothing else. That's why I told you guys before. You learn it the first time, you're good on everything we do. And I said that many, many times. So, I want you to graph. And if we graph, I want you to graph the parent function at y equals the square root of x. And I want you to graph its translation at y equals the square root of x plus 2 minus 1. So, first of all, I'm going to graph my original. The original parent function starts at the origin and curves around, starts to flatten out. Again, we're just sketching. Okay. Now, over here, my translation, this tells me I'm going to the left 2 and down 1. So we're going to take this whole thing, and that's exactly what we're going to do. We're going to go to the left 2 and down 1. So it starts here. I'll even put it in a different color. Starts here, and it's going to curve around. That's all I'm looking for today. Okay? Because I want to see that you understand the translation of it. Because that's stuff we have already done and should know very, very well. In order to translate this, we went left 2 and down 1. You have to take this same graph and move it to the left 2? Yes. Okay. All right, so let's try another one. I want you to graph. First, y equals the square root of x. And then I want you to graph y equals negative the square root of x minus 2. Alright, so first of all, I'm going to put on here, this is my original graph. Starts at the origin and curves around. This minus tells me it's going to do what? It's going to flip. And then we're going to go to the right 2. Perfect. So if I flip this, first of all, it technically is this side of it, right? But now I'm taking that same curve, I'm going to the right 2. So it's going to start here and curve. Okay? Alright. So, let's see, I'm on what, example 3? Alright. Example 3. Numbers 8 through 20. It's just going to say graph. And let's do something just a little bit harder. Let's say I have y equals 3 square root x plus 1 plus 4. Okay, so tell me about this translation right now. What is this 3 going to do? It's going to be a stretch of 3. How about in here? What's this going to do? Good. Left 1. And what's this going to do? Up 4. Awesome. All right. So, again, if at this point, if you do not want to put the original one on, you do not have to. I prefer to see it so you can see how it's moving. So if here's my original, if I stretch that, first of all, it's going to become, like I'm pulling up on it, it's going to become steeper. So it's actually going to be up here, right? That's the stretch. Then I'm going to take this and go to the left 1 and up 1, 2, 3, 4. So my actual finished one is this green one that's moved to the left 1 and up 4. So it's up here. You don't have to. I do it because it's a good starting point. You can see exactly what is moving as the curve. Okay? The red one's the final product. This is how it starts. Then it stretches, whatever's in front. Okay? The same thing when I had a negative and I kind of did a little dash underneath so you can see it before we move it right and left. Okay? You don't even need to reckon if you don't have to. It's just really hard for me to say, how did you know it went here? From out of nowhere, right? Okay? I just would like to see it. If you don't, that's fine. I'm not, Mhm. Well, when you stretch 3, you're actually stretching it a multiple of 3. So where it's here, I'm just pulling up because I said I just want a sketch for today. Okay? I just want a sketch. I want to see that you know it's stretching, right? The bigger the number, the steeper this is going to get, right? The smaller the number, the fraction, the flatter it's going to be. That's what I want to see you understand. That's the important part of this lesson. Okay? Okay. Sample number 4. On example number 4, this is numbers, let's go 22 through 24. It's going to ask you to solve by calculator. So, if you were given Let's say the square root of x minus 3 equals 12. I know you can do this algebraically, okay? However, there is more to learn from the calculator when we do it. Alright? Not always is it going to be this easy. I just starting with that one. So, what I want you to do, you have one of two choices. I know you guys know how to find your zeros in your calculator, right? So let's set this equal to 0. So how do I do that? Subtract 12. So I'm going to have the square root of x minus 3 minus 12 equals 0. Okay, so tell me what this means. If I were to ask you the translation, what's going on in this problem? Went to the right 3 and what? Down 12. Thank you. All right. So I'm asking you to graph it in your calculator. You should get something that, again, if you went to the right 3 and down 12, it's going to be way down here. You're looking for where it crossed the x-axis, and it may go out a while. You might have to expand your window to see that spot. All right? Zoom out. See where it crosses the x-axis. So you want to make sure, for example, your x values go out to like 150. Can you find where it crosses the x-axis? Yes. Okay? That's the idea. This spot right here is 147. You have to zoom out to find it. So you have a couple that you're doing in the calculator. Because again, we talked about how the calculator can find your zeros. Alright? So, same idea. What if I gave you this one? The square root of x plus 2 plus 3 equals the square root of, how about, I don't know, 2x minus 1. What do you want to do? Well, we'll just subtract it out. You can rewrite this as the square root of x plus 2 plus 3 minus the square root of 2x minus 1 equals 0. Right? So remember when we did this algebraically and you had to square it twice and go through the whole process? This you can put in your calculator and actually find out where it crosses the x-axis. Understand that's another option, and that's what I want you to learn. So grabbing your calculator, I will grab mine as well. It doesn't cross it. That's what I get for making up a problem. I'm sure you didn't. Oh, did you? Oops. So is everybody seeing it cross? Yeah, that's what I got too. Okay? So again, that's another method. You only have 2 problems you got to do that with in your homework, and that's it. All right? So it crosses the x-axis. You should have gotten a graph that kind of looks like this, and eventually it crosses out there. So you're looking for this point, which was at 58 point, what was it again? 8. All right. Okay. Let's go to what numbers, ma'am? the x value. Yeah, you got to do your 0. All right. Let me keep going, and just a minute, okay? Let me keep going, because if I help one person, some of your fellow classmates do other things. I will be right there. There's only 2 problems in your homework with it, but I'd like to keep going, okay? All right. I will come over and help you. Example number 5. All right. So in the next one, 26 through 30. It is asking you to graph. However, this one is a cubic function. So y equals the cube root of x is the parent function that looks like you actually have a or the square root up there, but it does the same thing going this way. This is the parent function for the cube root of x. So if I ask you to graph y equals the cube root of x minus 1 plus 4, what are we going to do to that function? Good. Right 1, up 4. So we're going to take this function, and we're going to take it to the right 1 and up 1, 2, 3, 4. And now our new function will be up here. Well, that wasn't very straight, but you know what I mean. Okay? So we're just taking that function and translating it. That's it. Okay? All right, last section then. Last example, and I'm done. If we're good with that. Again, it follows the same rules, same everything. All right, example number 6. In this last section, or last one, this is still part of that same thing. Let's say I have y equals 1/2 the cube root of x plus 2 minus 1. Alright, so what is this actually going to do? Yeah, it's going to flatten out, so this is a compressed, right? Good. What else is it going to do? Good. Left 2 and, I forgot my T, down 1. Awesome. Okay. So, if my original parent function is this cube root function that sits right here, this is going to get flatter. It's going to go to the left 2 spot, and it's going to go down 1. So here's kind of my middle point where the origin started, right? And it's going to be more of a flat section. So it's going to fall inside. Okay? Now you guys know, if you ever have a question of what it looks like, or you want to make sure you're right, that's why you have a graphing calculator. When in doubt, graph it out. Now, you can either type this into your graphing calculator with the cube root that's in the math function, or remember, you can type this into your calculators. 1/2 x plus 2 to the 1/3 power minus 1. That is the exact same thing, right? That's what this whole chapter is about. Alright. Okay, go ahead and open your books or your Chromebook to page 418.